This is Geometry Unit 3, Lesson 1 on slope. Slope is the ratio of the change in vertical distance, which we usually call rise, to the change in horizontal distance, which is the run between points in the line. So when you are going from point to point on a line, you are comparing the rise over the run. So how much you move up and down compared to how far you move to the right. Now, we know a formula for using slope. We did it back in Algebra 1. Remember, the variable that indicates slope is m, and the formula is delta y over delta x. Now remember, delta means change, so y2 minus y1 over x2 minus x1 means the change in y over the change in x. So when you want to figure out the values for slope, you just have to subtract them, but watch your order. So change in y over change in x. So let's try a couple problems. Find the slope of a line that passes through the points -3, 2 and 3, -1. So we would immediately put down our slope formula. I'm just going to use delta y over delta x. And we have to know which ones are the x's and y's and which order we're doing them. I like to do this so I know which one I've already used. x1, y1, x2, y2. So my change in y is going to be subtract the y's, subtract the x's in the same order. So -1 minus 2 over 3 minus -3. -1 minus 2 is -3. 3 minus -3 is 6. So -3 over 6 is -1/2. So the slope of the line between those 2 points is -1/2. To move from this point to this point and make the line, we would have to go down 1 and to the right 2. That's what the slope means. Now slope is slope no matter what happens. You can always figure out the slope if given 2 points, even if you don't know exactly what the points are. Find the slope of PQ if the coordinates of P are a plus b, and Q is 5a, b minus 2a. Well, just make this one x1, this one y1, this one x2, this one y2, and just follow the formula. M equals delta y over delta x. So subtract the y's. My first y, I'm going to put them in parentheses just so you can see separately where they are. B minus 2a minus a plus b. y2 minus y1 over x2 minus x1. So it's going to be 5a minus a. So you can see, even though if I have variables, you're still going to work out and get a slope. Let's see if we can simplify this. B minus 2a. Now remember, the minus has to carry through the parentheses. Minus a minus b over 5a minus a is 4a. Now simplifying the numerator, we have b minus b is just going to be 0, and then we have -2a minus a is -3a over 4a, and then the a's are going to cancel here, so your slope is actually going to be -3/4. So you can do this with general variables for any kind of slope when you're doing that. Don't let that throw you. It's still the slope formula, delta y over delta x. Now let's look at the different cases that we run into for slope. There are actually 4 different cases for slope. The first kind of slope we have is a positive slope. The positive slope says as x increases, which means if you're moving to the right, y also increases. So what would that look like? If you're moving to the right on the x and your y is also increasing, the line with a positive slope will rise from left to right. So when you have a line going left to right and it's going like this, it's going to be a positive slope. All right, let's graph the points and find the slope both algebraically and graphically. All right, so a, -1, -2. Let me do this in red. -1, -2 is right here. That's my point A. And my point B is at 2, 7. 1, 2, 1, 2, 3, 4, 5, 6, 7. So there's my B, and I'm going to draw a nice neat line to connect them using my ruler line drawer. Okay, so we need to find the slope of AB. So as we use the formula, if we use the formula delta y over delta x, the slope of AB is delta y over delta x. It is going to be 7 minus negative 2 over 2 minus negative 1. That's really bad 1. Sorry about that. 2 minus negative 1. 7 minus minus 2 is 9 because it's 7 plus 2. 2 minus minus 1 is 3. So 9 over 3 is 3 over 1. So what this is telling me as I move on the line from A to B, to get from A to B, my slope is up 3 and to the right 1. So let's try that out. If I start at point A and I go up 3, 1, 2, 3, and then go to the right 1, I end up 3, and then I went to the right 1 like this. I end up on the line. If I keep going, 1, 2, 3 over 1, 1, 2, 3 over 1, I will eventually get to point B, creating that line. So you'll notice as we go left to right, as I increase my x's, my y's are also increasing, so it makes the line go up from left to right. Now let's look at our negative slope. Let me do this one in blue. As x increases, if you have a negative slope, y will actually decrease. And so a line with a negative slope will actually fall from left to right. It'll go like this. It'll fall from left to right. Now let's see what that looks like. If we have the 2 points C and D, I'm going to do these in blue, I think. C is at 2, 3. 1, 2, 1, 2, 3. There's point C. And point D is at 5, 1. 1, 2, 3, 4, 5, 1. Is it D? If I connect my points, C to D, like so. And if I want to find the slope of CD, as my x's get bigger, as I move to the right, you can see the line is going down. So we can actually work this out algebraically, and then we'll do it graphically. So the slope of CD, which is m, is delta y over delta x, which is 1 minus 3 over 5 minus 2. 1 minus 3 is negative 2. 5 minus 2 is 3. So your slope is negative 2/3. So what does this mean we're doing as we move left to right? Well, your change in y is minus 2, which means you go down 2. And then positive 3 means you go to the right 3. Let's test this out. Down 2, to the right 3, and yeah, that worked. Now notice the down is the negative. The bottom number is positive because we are moving to the right. The third case for slope is kind of an oddball one. The zero slope is what we're going to look at. So if you have a zero slope, if you think of slope as a fraction, if you have a fraction, the 0 should be in the numerator. So as x increases, y doesn't change. So y is going to stay the same. Now what happens if you're moving from left to right and you're just moving left to right but you're not rising? What kind of line do you have? A line with a zero slope is actually a vertical line, or excuse me, a horizontal line, not a vertical line, sorry. It's a horizontal line. So the line does not rise, but it does run. And there is no change in y. So each point of the line will have the same y coordinate. That's how you identify a zero slope, because your y's will be the same. When you subtract them, you're going to get 0. So let's take a look at EF. Let me do EF and say green. So E is at negative 3, 2. 1, 2, 3, 1, 2. There's point E. And point F is at 2, 2. 2, 2. Here's point F. And if I draw my line from E to F, you can see that I have a horizontal line. So if I find my slope, m is equal to delta y over delta x, and I subtract the y's, I get 2 minus 2 over 2 minus negative 3, which is 0 over 5, which is equal to 0. Now notice, 0 is the change in y. We are not changing y. Technically, this can be, the bottom number can be any number you want. we are going to run, but we're not going to rise. So the slope of EF is actually going to be 0. Now, here's the tricky one. Undefined slope. An undefined slope is not the same as a zero slope. You have to think about how your slope works. So as for an undefined slope, as y increases, this time y is increasing, x stays the same. Now notice I said the y first. Because a line with undefined or no slope is actually a vertical line. The line does rise, but it does not run. So there is no change in the x. So each point in the line will have the same x coordinate. Now think about this for a second. If you think about how your slope works, if we look at the values for slope, if the values on the denominator are 0, doesn't that make it undefined? Yeah, remember you can't divide by 0. That's one of our 10 commandments of math. You cannot divide by 0. So let's graph our points and see what we end up with when we do this one. So we are going to graph the points g negative 3, negative 2, and h negative 3, 1, and find the slope of gh. So let me flip back here. So g was at negative 3, negative 2. Let's do this one in purple. Negative 3, 1, 2, 3, negative 2, right there. There's g. And my other point was negative 3, 1. 1, 2, 3, and then 1 would be right there. There's h. Now notice those two coordinates have the same x coordinate. This line is rising, but it's not running. So when we actually work out the slope for this line, the slope of GH, which would be m, is equal to delta y over delta x, 1 minus negative 2 over negative 3 minus 3, minus negative 3, I'm sorry. 1 minus minus 2 is 3. Negative 3 minus minus 3 is 0. That's undefined. So that is our fourth case for slope. Undefined slope means there is no slope. It does not mean it's a zero slope. A zero slope is a horizontal line. It has a slope of 0. It actually has a value. Undefined means there is no slope. It means it's going to be a vertical line. So we have talked about slope. You will need to know the slope formula. You should know it by now. We've done it many times. You also have to know the cases for positive, negative, 0, and undefined or no slope. So that is what we're going to be having our homework on the next lesson.